Part B, function notation. I just want to quickly review f of x notation and plugging into functions. We're going to look at the function f of x equals x squared minus 1, and for our first example, I want to find f of 2c. Anytime you're plugging in something more complicated than a positive whole number, put what you're plugging in parentheses. I'm going to replace the x with 2c, and I'm going to get 2c in parentheses squared minus 1, 4c squared minus 1. Make sure you distribute the square to both the 2 and the c. f of 2c equals 4c squared minus 1. Next, I'm going to use the same function, and I want to find f of 3 plus a. Well, this is going to equal 3 plus a in parentheses squared minus 1. Remember that to square a sum or a difference, you need to write it out twice and do your multiplication. So 3 plus a times 3 plus a minus 1. This gives me 9 plus 3a plus a squared minus 1. And combining like terms, I get a squared plus 6a plus 8. So f of 3 plus a equals a squared plus 6a plus 8. Finally, a little bit more complicated now. I want to look at the formula f of x plus delta x minus f of x over delta x. We're going to see something like this formula a little bit later on in the course when we start looking at finding the derivative, finding the slope of a line that's tangent to a particular function. For right now, though, we're just going to treat this like a normal function problem. Notice that I have an x and I have a delta x. I'm going to treat those as just two separate variables. X, I'll keep alone, and delta x, those two symbols together, will make up my second variable. I realize that x and delta x have some connection between them, but for right now, I'm going to treat them separately. Now, to deal with this, rather than trying to figure out the entire thing all at once, I think I just want to separate things and just focus, first of all, on my f of x plus delta x. Remember that the original function was f of x equals x squared minus 1. So if I want to find f of x plus delta x, I'm going to get x plus delta x in parentheses squared minus 1. Write it out twice, so x plus delta x times x plus delta x minus 1, and multiply. X times x will give you x squared. X times delta x is just going to give us x times delta x, or x delta x. Delta x times x will give us another x delta x. And finally, delta x times delta x, I'm going to need some parentheses here, and I'm going to say delta x, that variable, squared, minus 1 at the end. Combine like terms, and we get x squared plus 2x delta x plus delta x in parentheses squared minus 1. Now I'm going to go and return to that original problem and try to fill in a few other pieces. I want to find f of x plus delta x minus f of x over delta x. Well, I know my f of x plus delta x by now. I have my x squared plus 2x delta x plus delta x in parentheses squared minus 1 minus f of x is just my original function, my original x squared minus 1. Make sure when you go to plug it in, you put that in parentheses because we're going to need to distribute that negative. And this is over delta x. Distributing the negative, we get x squared plus 2x delta x plus delta x in parentheses squared minus 1 minus x squared plus 1 all over delta x. And I can make the x squareds cancel and the 1's cancel, leaving me with 2x delta x plus delta x in parentheses squared over delta x. There's a little bit more simplifying that I want to do, and there are actually two ways we can go about doing this. First, just rewriting the problem, 2x delta x over delta x plus delta x in parentheses squared. I can separate my fraction and put both parts over that denominator of delta x. This is a trick we're allowed to do whenever there's a single term in the denominator. If we had a sum or difference, we wouldn't be allowed to do this. By separating it like this, I can now cancel my delta x's over there and cancel a delta x over here, so we're left with 2x plus delta x. Another way we could have finished this off, I had 2x delta x plus delta x in parentheses squared over delta x. I can take that numerator and factor out a delta x since both pieces have a delta x in common. Take out a delta x, and we get delta x, times in parentheses 2x plus delta x, and this is all over delta x. I can make those cancel, and I'm left with that same answer of 2x plus delta x. Either way will work as far as your simplifying goes.